Hey guys, it's Mrs. Marquette. Today we're on day 2 of our factor chapter notes. Our goal today is that we're going to be adding and subtracting polynomials. And a polynomial is an expression, so it's without an equal sign. It's an expression that has coefficients, a variable, and a power. And it might have multiple of those terms that are written together kind of like a number sentence, so an expression. So standard form of polynomial looks kind of like this. I have a variable, or I have a coefficient, then I have a variable, then I have a power, and I might have that several different times. So an example of that is here. An example would be 5x squared minus x minus 1. So 5x squared is one term of my polynomial, negative 1x is my second term, and negative 1 is my third term. What you won't be seeing today are things like our non-example here, 3 over x with x in the denominator. That's not a polynomial, so we're not going to be asked to add or subtract those. When we're adding or subtracting polynomials, it's going to be pretty straightforward. You've already done something like this in chapter 1. It's kind of nice. We're going to be subtracting or adding the coefficients of like terms. And we know what like terms are. Like terms are terms that have the exact same variable part. So x and x are like terms. P and p are like terms. Y squared and y squared are like terms, and so on and so on and so on. So let's do an example here. Number 1, 3x cubed plus 2x squared minus x minus 7 plus x cubed minus 10x plus 8. I'm adding here, so I can just add all of my like terms. I look first, I have an x cubed term and an x cubed term. They're lined up, so I can just add straight down. I've got 3 plus 1 is 4. My x cubes don't change. You think about like adding apples. If you have 3 apples and then one more apple, the apple doesn't change, the thing. It's just how many I have. And then I've got x squared terms. I have 2x squared minus 10x squared, so I subtract or I add those coefficients. 2 plus negative 10 is negative 8. The x squareds do not change. They stay the same. My next term, negative x, is in the top polynomial. In the bottom polynomial, I don't have any x's. So I can kind of say like there's 0 x's down there. Negative 1x plus 0x is still negative 1x. And then negative 7 plus 8, that's an easier one, that's just 1. So that is my final answer. I would take that. If you have a 1 in front of a variable, we know that 1 times anything is just that thing. So I can really write this as 4x cubed minus 8x squared minus x, because 1 times x is x, plus 1. What you will see is that when you write polynomials, we write in descending order. So here our cubed term is first, then our squared term, then our x to the first term, and then our constant term. All right, let's go to number 2. You saw in number 1 that we had a vertical alignment of our polynomials. For number 2, my polynomials are next to each other. So you can do a couple things here. First of all, I'm adding, so I don't really need to distribute anything because there's just a 1 out here. So I can rewrite this as just 9x cubed minus 2x plus 1 plus 5x squared plus 12x minus 4. I'm going to be looking for like terms. So I'm going to start with my highest power that I see. So I've got 9x cubed. I don't really see any other 9 or x cubed terms. So that's like 9x cubed plus 0x cubed. That's the only one, so I'm just going to write it down. My next term, I'm going to look for x squared terms. It looks like I have a 5x squared, but no other x squared terms. It's pretty easy so far, so I've got just 5x squared. It stays the same because nothing is added, nothing is subtracted. After that, I've got my x's. I have negative 2x and 12x. Negative 2x plus 12x is a positive 10, because negative 2 plus 12 is 10. And then my x's don't change. And finally, I have positive 1 and negative 4. Positive 1 and negative 4 is negative 3. So you can do this way where you kind of just keep track of your like terms. I like to underline, so sometimes I'll underline if I'm just using pencil something 3 times if it has an x cubed, twice if it's an x squared, once if it's an x, so then I see that I've got like terms, so that I'm making sure that I keep track of all of my like terms. Otherwise, you can rewrite this. I could have rewritten and lined up my 9x cubed. I'll leave a space for my 0x squareds, negative 2x plus 1 plus 5x squared. Again, I'm going to line it up with its like term, plus 12x minus 4. And then I could do what I did in the last one, 9x cubed plus 5x squared. Ooh. Excuse me there, my iPad went crazy. 5x squared plus 10x minus 3. So you'll get the same answer either way. It's kind of just how you like to organize your work. If you like the horizontal way, this will work just fine for you over here. If you like to have things vertical, so you can see your x cubes, your x squareds, your x's, and your constant terms, that's fine too. You got to pick a method that works for you. All right, number 3, now we're getting into subtracting. So I have the top polynomial minus the entire second polynomial. The thing to be careful about when you subtract, so these are going to be the tougher ones today, is this is really times a negative 1. So when I do my adding or subtracting, I first need to distribute my negative 1 to all of the terms of my polynomial. So I'm going to rewrite this just to be really careful. I'm going to say 8x cubed minus 3x squared minus 2x plus 9. Now that I've distributed my negative, or once I do, this can then become an adding problem. So negative 1 times 2 is negative 2x cubed. Negative 1 times 6 is negative 6x squared. Negative 1 times negative 1x is a positive 1. Or sorry, yeah, positive 1x. And then negative 1 times positive 1 is just negative 1. This is lined up just like I want it to be. So I get 6x cubed. The x cubes stay because I'm only changing the coefficients. Negative 3x squared minus or plus negative 6x squared is a negative 9x squared. Negative 2x plus 1x is negative 1x. And then I get positive 8, 4, 9 plus a negative 1. Make sure that everything's in order. It is. I don't really need that negative 1 because negative 1 times x is just negative x plus 8. And that is my final answer. If you are able to kind of see this in your head, when you distribute your negative, I can make this a negative 2, a negative 6, a positive x, and a negative 1. As long as you're really keeping track of all of those pieces, it's okay for you to skip the step of rewriting everything. Just make sure you change all the signs. Let's do that for number 4. If I put a negative 1 in front of my second polynomial, because I'm subtracting, I'm going to distribute that negative 1. I get 2x squared plus 3x. Now it's minus 3x squared minus, I'm going to put a 1x just to keep track of that. And then negative 1 times negative 4 is a positive 4. Again, please make sure you change all the signs. I'm even going to write it for extra emphasis. You should too. And then we'll combine some like terms. Actually, I'll stay in blue. My x squared terms, 2x squared plus a negative 3x squared. That's negative 1x squared. 3x plus negative 1x. 3 plus negative 1 is 2x. The x's don't change. And then 4, this one's kind of a lonely guy. He doesn't have anyone to add like terms with, so I just have a plus 4. Negative x squared plus 2x plus 4 is my final answer. Depending on the book you see, like if you take another like college algebra class in a couple years, they might also write this as a negative x squared minus 2x minus 4. This is the exact same thing. We'll see why in a couple days. But if I look at this red one, if I distributed in a negative 1, I would get right back to my blue negative x squared minus or plus 2x plus 4. So sometimes books will like to write it in the way that it's written at the bottom. Just know that that's going to be exactly the same as our answer in the blue. So I'm okay with either one of these. Okay, I want you to try each one of these. I will give you about we'll go 30 seconds to try A, and then I'll show you, and then we'll go through B, C, and D. Okay, checking your work. We get a 5x to the 4th plus 3x cubed minus 5x squared plus 7x minus 18. Likely 30 seconds was way too long, so we'll go shorter on the next one. So please go ahead and try B. It looks like you are now subtracting, so remember what that means. All right, so we're remembering that the negative means I'm going to distribute a negative to all three pieces. 9x squared minus 5x plus 3 minus 3x cubed plus 5x squared minus 7. Combining your like terms, I get negative 3x squared plus 14x squared. Oh, I'm sorry, that first one should have been cubed. Plus 14x squared. Our x's, it looks like negative 5x doesn't have a like term. And then positive 3 and negative 7 is negative 4. That's our final answer. Number 3, we're horizontal this time, but we have addition. So go ahead and add your like terms. I don't need to distribute, so I can just rewrite this. If you didn't rewrite it, that's totally fine. But I can combine 8 and 5 to get 13x squared. I can combine my 1 and negative 4 to get negative 3. And that is a polynomial. Final one, go ahead. On this one, you'll notice that my 16 and negative 3x, they're not written in descending order, But that's okay if we're just asked to add. We'll just put ours in descending order in the end. So I look, my highest power is an x cubed, so I'll go 3x cubed, or squared, 3x squared first. Then I've got x's. Negative 3x plus x is negative 2x. And then 16 plus a negative 4 is 12, positive 12. And that is all we have for today. If you need to go over any of these again, go ahead and do that. Just rewind the video, watch again. Otherwise, you've got practice problems that will help you with this. Remember, you're adding like terms, combine the coefficients, but your variable part does not change. So x squared plus x squared is not x to the fourth. It's just 2x squared. See you guys later.